Hello everyone, welcome to my channel Dr. Tapati's presentation. Myself Dr. Tapati Bhansate. In my last video, I have discussed about the Michaelis-Menten equation. I have shown that if you plot V0 versus substrate concentration curve, you will get a rectangular hyperbola curve following the Michaelis-Menten equation. We know that curve plots are more complicated as compared to linear plots. Therefore, it is very difficult to get the exact values of Km and Vmax from the rectangular hyperbola curve. Km and Vmax are very important parameters of enzyme kinetics. Therefore, it is very necessary to linearize the Michaelis-Menten equation to get accurate values of Km and Vmax. Today, in this video, I am going to show you how to linearize Michaelis-Menten equation. You can get more accurate values of Km and Vmax from those linear plots.
In this unit, I will cover following topics. First one is non-linearity of Michaelis-Menten equation. Then linear plots of the Michaelis-Menten equation. There are three plots. First one is Lineweaver-Burk plot. Second, Eadie Hofstee diagram. And third one is Hanes-Woolf plot. After that, I will discuss about the non-linear regression kinetics. Let's start with the non-linearity of Michaelis-Menten equation. This is a plot of the initial velocity versus substrate concentration of a simple Michaelis-Menten reaction, where Michaelis-Menten equation is V0 is equal to Vmax into substrate concentration divided by Km plus substrate concentration. This is not a linear equation. We got this hyperbola curve following this equation. So from this non-linear plot, it is very difficult to get Vmax value from this area. As you know that Km is equal to substrate concentration at half Vmax. Therefore, if you don't know the exact value of Vmax, it is very difficult to estimate the exact value of Km also. Straight line plots are easier to evaluate than curves. Therefore, several scientists linearized the Michaelis-Menten equation such as Lineweaver-Burk plot, Eadie Hofstee diagram, and Hanes-Woolf plot. From these plots, we can get more accurate values of Km and Vmax as compared to nonlinear equation of Michaelis-Menten. One by one, I am going to discuss about these three linear plots of Michaelis-Menten equation. Let's start with Lineweaver-Burk plot or double reciprocal plot. Lineweaver-Burk equation of enzyme kinetics was described by Hans Lineweaver and Dean Burke in 1934. As you know, this is the Michaelis-Menten equation. V0 is equal to Vmax into substrate concentration divided by Km plus substrate concentration. If you take reciprocal of both sides, this side as well as left side as well as right side, if you reciprocate those two sides, we will get 1 by V0 equal to Km plus S. This part is going upward because we are taking reciprocals. So it becomes this 1 by V0 is equal to Km plus S divided by Vmax into substrate concentration. Or we can write it in this way: 1 by V0 is equal to Km divided by Vmax into 1 by substrate concentration. If you in this way, you can cut right hand part to two different parts, you will get Km by Vmax into 1 by S plus S divided by Vmax into S, as we can cancel S and S, therefore we will get 1 by Vmax. So overall Lineweaver-Burk equation is 1 by V0 equal to Km by Vmax into 1 by S plus 1 by Vmax. It is like a straight line equation, like y equal to mx plus c, where y is equal to 1 by V0, m is Km by Vmax, and c is 1 by Vmax. You can also plot initial velocity, that is 1 by V0, that is y, it is in y axis, initial velocity, 1 by initial velocity, 1 by initial velocity in y axis, or if we plot 1 by substrate concentration in x axis, then we will get this type of graph, straight line. It's a straight line graph. In that case, C value is, C means intercept of y axis is 1 by Vmax. It is there. I hope you are understanding it. Intercept, that is C value. C value is this part, 1 by Vmax. This is already, it is given in the graph that this intercept is 1 by Vmax. This intercept, this point is 1 by Vmax, and slope is Km by Vmax. Km by Vmax. Here it is the slope, that is m value, Km by Vmax. So again I am telling that plotting 1 by V0 against 1 by substrate concentration gives a straight line, with slope Km by Vmax and an intercept of 1 by Vmax on 1 by V0 axis, and intercept on 1 by S axis, that is minus 1 by Km. If you see this figure, you will see that you can feel that the x-intercept, this point, this which is minus 1 by Km, is an extrapolation of a experimental data taken at positive concentrations, because substrate concentration can't be negative, so we can experimentally get only we can draw only this part, but in order to get the x-intercept, we have to x-intercept. Why we need x-intercept? Because we have to calculate the value of Km very easily by knowing this x-intercept value. So in that case, we have to extrapolate this straight line to negative part. This is the negative part, because it is going towards left side from 0 axis. So overall, this is the Lineweaver-Burk plot or double reciprocal plot. Why double reciprocal? Because both of the side we are getting the reciprocals of Michaelis-Menten equation. So it is double reciprocal plot. I told you that x-intercept value is minus 1 by km, but why x-intercept is minus 1 by km? Let's determine it or calculate it. How it is coming from the Lineweaver-Burk plot. As you know, this is already in my last slide I have told you. This is the Lineweaver-Burk plot. Lineweaver-Burk equation, that is 1 by V0 is equal to Km by Vmax into 1 by substrate concentration plus 1 by Vmax. It is like a straight line. Already I told you here y value is 1 by V0 and m value is Km by Vmax, and x is 1 by S plus 1 by Vmax. It is like a straight line. Now, in order to calculate this value means it is x value is, if you imagine it is x, and here the y coordinate is, y value is 0. We have to calculate the x value from this Michaelis-Menten, Lineweaver-Burk equation. If you put y value as 0 here, see y value is 1 by V0, that is if you write y value is 0, because in this point x-intercept point the y value is 0, that means 1 by V0 is equal to 0. So we are putting 0 in this equation. So we will get 0 is equal to 1 Km by Vmax into x. If you imagine x is the x-intercept value, this one, then and then plus 1 by Vmax. Or you can write this equation as Km by Vmax into x, that is equal to minus 1 by Vmax. Here, I hope you are understanding it. Now, we can calculate that x is equal to minus 1 by Km, because if Vmax and Vmax is cancelled, or if you calculate this x value, then Km will come to the denominator. So x value is equal to minus 1 by Km. So it is proved that the x-intercept value is minus 1 by Km. As I told you, main purpose of linearization of Michaelis-Menten equation is to calculate Km and Vmax value. Let's know how to calculate these two values using Lineweaver-Burk plot. You will understand through an example. This is the question where if the y-intercept and x-intercept on a Lineweaver-Burk plot are 0.6 and minus 4 respectively, then calculate the Km and Vmax values. Y-intercept is this point, that is 1 by Vmax value, and x-intercept is minus 4. So this is the point for x-intercept. That means minus 1 by Km is equal to minus 4, whereas 1 by Vmax is equal to 0.6. again you can write in this way: y-intercept is equal to 1 by Vmax, that is equal to 0.6. So we can calculate Vmax value from this 1 by Vmax value. If you reciprocate it, then it will get 1 by 0.6, that is equal to 1.67. Now x-intercept is minus 4, that is equal to minus km, or km is equal to 1 by 4, that is equal to 0.25. Here minus and minus is cancelled, minus cancelled, so km value is 0.25. In this way, if you know the x and y intercept value, you will calculate km and Vmax value. Or if you know slope of the curve or any one of x or y intercept, then also you will calculate km as well as Vmax value of our Lineweaver-Burk plot. Let's compare Michaelis-Menten plot versus Lineweaver-Burk plot. This is the Michaelis-Menten curve, that is rectangular hyperbola. In this case, if substrate concentration is increased, V0 will increase. Hence, with the increase in substrate concentration, we have to plot substrate concentration towards right hand in this way, or it is the, as you know, it is the positive side. Whereas if you see the Lineweaver-Burk plot, in this case, if substrate concentration is increased, 1 by S will decrease. Therefore, with the increase in substrate concentration, we have to plot 1 by S towards 0 or towards the negative side. If you increase substrate concentration, then 1 by substrate concentration will be decreased. Therefore, we have to plot it towards the 0 point or negative side. These are the two difference. Here we are plotting towards positive side. In case of Lineweaver plot, we have to plot towards negative side because it is 1 by S. Similarly, a greater reaction velocity decreases the value of 1 by V0. So, if you plot 1 by V0, you can see that with the increase of V0 value, 1 by V0 will be decreased. So here these points are for higher substrate concentration, whereas these points are for lower substrate concentrations. Although double reciprocal plots are more useful as compared to Michaelis-Menten equation for the calculation of Km and Vmax value, there are disadvantages of this plot. The disadvantage of this plot is that it depends on less precisely determined points obtained at low values of substrate. It is mainly, you can see already I told you that it is these points are for lower substrate concentration, because 1 by S value will be higher in that case, and this straight line or this plot is dependent on less precisely determined points. These are the less precisely determined points which at low values of substrate concentration, whereas the more accurate points which are present here in this cluster, whereas the more precisely accurate points obtained at high values of substrate concentration cluster and so are less valuable, because as I told you these points are at low substrate concentration. Dependency on V0 is not so powerful. Therefore, although in case of double reciprocal plot, it is mainly dependent on the lower concentration of substrate. We are plotting the straight line depending on the lower concentration of substrate. Therefore, it is less valuable in establishing the linear plot. You can see that here a lot of clusters are it is a cluster of points at higher substrate concentration, but at lower substrate concentration points are perfect depending on that the straight line is drawn. The Lineweaver-Burk plot is correct when the enzyme kinetics obey in ideal second order kinetics. The x-axis goes into negative values. In this case already I told that x-axis goes into negative values. These are the negative we are extrapolating. However, there is no such thing as negative substrate concentrations, because substrate concentration can't be negative. Instead, researchers have to use this graph to extrapolate. This is the extrapolation part. To extrapolate data from a hypothetical situation in which a negative substrate concentration exists. So, it has the disadvantage of compressing the data points at high substrate concentrations into a small region and emphasizing the points at low substrate concentrations, which are often the least accurate. Lower concentration of substrates are least accurate, and the high substrate concentration points are compressed. Here we are getting a cluster at higher substrate concentration. Therefore, we can say it has the inaccuracy problem. Let's solve a numerical problem of Lineweaver-Burk plot. Question is, the Lineweaver-Burk plot of an enzyme catalyzed reaction shows Km value of 50 micromole per liter and Vmax of 150 micromole per liter per minute. What is the velocity of the reaction for a substrate concentration of 25 micromole per liter? We have to calculate velocity. Km and Vmax values are given, and substrate concentration is also given. As you know, the Lineweaver-Burk equation is 1 by V0 is equal to Km by Vmax into 1 by substrate concentration plus 1 by Vmax. Here Vmax is equal to 150. Here it is given. It is 150. Km value is 50 microliter. It is given in the question. Km value is 50 microliter and substrate concentration is 25 micromole per liter. It is 25 micromole per liter given in the question. So let's solve it. Then 1 by V0 will be 50 divided by 150. 50 is for Km value and 150 is for Vmax value, into 1 by 25, that is 25 is the substrate concentration, plus 1 by 150. 150 is Vmax value, that is equal to 2 by 150. 2 by 150, if you solve it, you will get this value. 2 by, if you cut this with 2 into 25 is equal to 50, so you will get 2 by 150 from this part. We will get 2 by 150, that is plus 1 by 150. It is given here. So if you add it, it will be 3 by 150 or 1 by 150, or we can say V0 is equal to 50 micromole per liter per minute, because 1 by V0 is 1 by 50, then V0 is 50. This is the answer. Now second linearized plot is Eadie Hofstee plot. The Eadie Hofstee plot represents an improvement over the Lineweaver-Burk plot. Improvement of over the Lineweaver-Burk plot, in that the experimental points are usually more equally spaced. If you compare these two plots, this is Lineweaver-Burk plot, and second one is Eadie Hofstee plot. You can see that clearly in Eadie Hofstee plot. All the points, experimental points, are more equally spaced. See, these points are equally spaced, whereas in case of Lineweaver-Burk plot, you can see few cluster. It is not equally spaced. All the points are not equally spaced in case of Lineweaver-Burk plot, but it is equally they are equally spaced in case of Eadie Hofstee plot. How? Let's know the what is the equation of Eadie Hofstee plot. That as you know that Lineweaver-Burk equation is 1 by V0, that is equal to Km by Vmax into 1 by S plus 1 by Vmax. If you multiply both sides with Vmax, we get Vmax divided by V0, Km by Vmax into Vmax by S plus Vmax by Vmax, because we are multiplying Vmax both sides. Or we can solve it as Vmax by V0 is equal to Km by S, as we can cancel Vmax and this Vmax, and we can cancel this Vmax and this Vmax, and in that case we will get Vmax by Vmax means 1. So we are getting this simple formula, Vmax by V0, that is equal to Km by S plus 1. or we can write it as Vmax is equal to Km by substrate concentration into V0 plus V0. V0 is multiplied here the right hand side. So we are getting this equation, or we can write V0 is equal to Vmax minus Km into V0 by substrate concentration. If you plot V0 against V0 by S, because in this case V0 means if you consider it as Y, and Km is the M value and V0 by S is X value and Vmax is Y intercept, that is C. So we will get this straight line, this type of straight line, where slope is equal to minus Km. It is written here, it is minus Km, and intercept on V0 is Vmax and Vmax by Km, this value is Vmax by Km, whereas this value is this value is Vmax. Let's discuss what are the advantages and disadvantages of Eadie Hofstee plot. First of all, advantage: it is also more robust against error-prone data than the Lineweaver-Burk plot, particularly because it gives equal weight to data points. Already I told that in any range of substrate concentration or reaction velocity, whereas the Lineweaver-Burk plot unevenly weights such points. You can clearly see the difference of these two plots. Now, what is the disadvantage? One drawback from Eadie Hofstee approach is that neither ordinate nor abscissa represent independent variables. Both are dependent on reaction velocity. Here you can see it is V0 and in this case it is V0 by S. Thus any experimental error will be present in both axes, because in both axes V0 value is there. Furthermore, the typical measure of goodness of fit, the correlation coefficient R, is not applicable in this case. Third linearized equation is Hanes-Woolf equation, and this is the plot of Hanes-Woolf. Similar to the Eadie Hofstee plot, the Hanes plot starts with Lineweaver-Burk equation, and Hanes-Woolf plot is devised by Charles Hanes and Barnett Woolf. Now I am writing Lineweaver-Burk equation, starting with Lineweaver-Burk equation. This is the Lineweaver-Burk equation, that is 1 by V0 is equal to Km by Vmax into 1 by S plus 1 by Vmax. If we multiply both sides with substrate concentration, we get substrate concentration divided by V0, that is equal to Km by Vmax plus substrate concentration divided by Vmax. We will get this value if you multiply substrate concentration with Lineweaver-Burk equation. Whereas in case of Eadie Hofstee plot, in Eadie Hofstee equation, we were multiplying Vmax with Lineweaver-Burk equation. Now, if you rearrange this equation, then we will get this is as the final equation, which is substrate concentration divided by V0 is equal to 1 by Vmax into substrate concentration plus Km by Vmax, which is similar to y equal to mx plus c, where y is s by v0. Here we are plotting s by v0 in y axis, and m value is 1 by vmax. This is the value for 1 by vmax. X value is substrate concentration. We are plotting substrate concentration by V0 versus substrate concentration plot, and in that case C value or y-intercept value is Km by Vmax. Here in this plot, this point is Km by Vmax, and slope is 1 by Vmax, and x-intercept is minus Km. You can see compare these two graphs. This is Lineweaver-Burk plot and this is Hanes-Woolf plot. Although they are both of their result of extrapolation data, you can see that all the points, all the substrate concentration points are uniformly spaced, whereas in case of Lineweaver-Burk plot, all the points are not uniformly spaced, few clusters are there. Let's know disadvantage of Hanes-Woolf plot. Hanes-Woolf plot is the most accurate of the three linear plots. However, its major drawback is that neither ordinate nor abscissa represents independent values. Both are dependent on substrate concentration. So this is the disadvantage of Hanes-Woolf plot. We are plotting S divided by V0 versus substrate concentration, and another disadvantage is also that we have to extrapolate it, and here we are getting substrate concentration as the negative value here in this point, which is not possible in practical. It's just an imagination. Let's summarize all the equations from this unit. First equation is Michaelis-Menten equation, that is V0 is equal to Vmax into substrate concentration divided by Km plus substrate concentration. And second equation is Lineweaver-Burk equation, which is 1 by V0 is equal to Km by Vmax into 1 by substrate concentration plus 1 by Vmax. We are getting this equation by the reciprocal after reciprocal of two sides. We are getting this Lineweaver-Burk equation or double reciprocal equation. Then Eadie Hofstee equation, that is V0 is equal to Vmax minus Km into V0 by S. And then fourth equation is Hanes-Woolf equation, which is substrate concentration divided by V0 equal to 1 by Vmax into substrate concentration plus Km by Vmax. First one is for nonlinear equation. Michaelis-Menten equation is non-linear equation, whereas these three equations are linear equations. They are similar to y equal to mx plus c linear equation. Let's quickly summarize all the three linear kinetic plots. If you compare the equation, you will find that for Lineweaver-Burk equation is 1 by v0 divided by 1 by v0 is equal to km by vmax into 1 by s plus 1 by vmax, whereas equation for Eadie Hofstee, it is v0 is equal to vmax minus km into v0 divided by s, and for Hanes-Woolf equation, it is S substrate concentration S divided by V0 is equal to 1 by Vmax into S plus Km by Vmax. These three equations you have to remember. From these three equations we can get y-axis value, x-axis value, y-intercept, x-intercept as well as slope. In case of Lineweaver-Burk equation, x-axis value is 1 by V0, y-axis value we are plotting 1 by s. So in case of Lineweaver-Burk, we are plotting 1 by v0 versus 1 by s. In that case, y-intercept is 1 by vmax. From this equation you can get y-intercept value, that is 1 by vmax, and x-intercept is minus 1 by km. If you can get this value from m value, this slope value also. If you put slope is equal to km by vmax, that is y by x value, and here y value is 1 by vmax, then you can get x value which is minus 1 by km, although the minus value is because we are extrapolating the graph, and therefore x-intercept is minus 1 by km. It is the negative value. It is the negative value. And in case of Lineweaver-Burk plot, slope is km by vmax. You can get this value from the main equation. Now if you compare, or if you see the Eadie Hofstee equation, you can find that the graph is v0 versus v0 by s, and y-intercept is vmax, you can see from this equation, and x-intercept is vmax by km, and slope is minus km. You can find it from this equation. And next, third equation is Hanes-Woolf equation. In that case, we are plotting S by V0 versus S. In that case, y-intercept is km by Vmax. It is the C value for y equal to mx firstly equation. So it is y-intercept km by Vmax, and x-intercept is minus km. Again, we are getting this value by extrapolating the graph. And slope is 1 by vmax. You will get this value from the main equation. So you don't have to remember all these things. You have to remember mainly these three equations. From these three equations you will get other values like x-axis, y-axis, y-intercept, x-intercept, and slope. You will find out from these three main equations. Although there is a disadvantage of Lineweaver-Burk plot, but it is widely used by enzymologists in general, whereas the Eadie Hofstee and Hanes plots are favored by enzyme kineticists. And Lineweaver-Burk plot is favorite for enzymologists. In general, we calculate Km and Vmax value from Lineweaver-Burk plot. However, nowadays those linear plots are only used for visualization of the data, not for the determination of the kinetic parameters, because computer software is readily available nowadays, and which allows for more accurate, you have to remember it, we will get more accurate data from computer software. So it allows for more accurate determination of kinetic parameters by linear, remember, linear regression method, by linear regression method, which is carried out by computer software. Nowadays it is popular as compared to these linear those three linear plots. From non-linear regression method we can calculate Km and Vmax value by computer software. Let's know shortly about non-linear regression kinetics. In order to reduce the errors due to the linearization of parameters, Wilkinson in 1961 proposed the use of least squares non-linear regression for more accurate estimation of enzyme kinetic parameters. As I told you that for each of the linear equations there are disadvantages. So Mr. Wilson proposed least squares non-linear regression model for the accurate estimation of enzyme kinetic parameters. Those are Km and mainly Vmax, and it is a general technique to fit a curve through the experimental data, and it fits data to any equation that defines y as a function of x and one or more parameter. Linear regression kinetics allow direct determination of parameter values from untransformed data points. It finds the values of those parameters that generate the curve that comes closest to the data, which minimizes the sum of squares of the vertical distances between data points and curves. The process starts with initial estimates and then iteratively converges on parameter estimates that provide the best fit of the underlying model to the actual data points. Nonlinear regression requires a computationally intensive iterative approach where the algorithms are used. Name of the few algorithms are the Leeuwenhoek-Marquardt method, the Gauss-Newton method, steepest descent method, and simplex minimization method. And numerous software packages are used, namely Excel, MATLAB, GraphPrism, and nowadays include readily available routines and scripts to perform nonlinear least squares fitting. Comparison of linear regression method and nonlinear regression method. Unlike the linear regression method, nonlinear regression allows direct calculation of the actual values of Km, Vmax as well as estimates of their standard errors, whereas the former method gives only apparent values. Former method means the linear equations, linear regression methods give only apparent values. The nonlinear regression technique is also statistically a more valid means of analysis, as the rearrangements required to give linearized equations will considerably distort the error distribution and render simple unweighted linear regression inappropriate.
Thank you very much for watching this video. Kindly like, share and subscribe this channel. Don't forget to press the bell icon to get the notification. Take care. Bye bye.